Hi, and welcome to this new short demo of our new reference app and example source code for orthognathic surgery planning using Polygonica. So I'll just run the example. So what we have here is a console application. So let me just get the windows somewhere reasonable. And we've done it this way because there's a lot of selection operations, as you'll see in the demo, and it's quite tricky to select the right parts of the skull. That's why we've pre-recorded it, but it is actually doing live. So we've recorded the camera locations for the selection operations, but we are doing everything live. So what you're seeing is Polygonica actually working. It's not a video. Okay, so first of all, let me go into playback tool, press P for playback. Let's go to the start. Okay, so here's our skull. So it's a scan of the patient's skull, jaw, etc. And the surgeon needs to realign the jaw areas. So what they're going to do is they're going to make cuts. They're going to shift the bones after having made the cuts, and then they're going to create strip plates to anchor the bones in the new positions. So that's what I'm going to show you here. So let's start off. We'll just make the skull transparent so we can see a bit what's going on. And then you'll see how complex it is to make these cuts. So I'm looking from the side, and we've got a rectangle that's cutting through the chin. If you just look at that from the front, you can see it's made a cut right through the center of the chin. I'm not sure that's necessarily accurate. You probably perhaps cut in from the side, but you cut in from the side first rather than cutting that bit first. But hey ho, it's only a demo. But you can see the principle. You've got a cutting tool, and Polygonica's Boolean operation can do the Boolean subtractions for you. So I'm just going to skip through these, and you'll see what happens. I mean, it's much more complex on the upper jaw area. There's a lot more going on, so you have to be very careful what tool you use and how you position it. So again, those aspects of the surgical planning can be covered in this. This is just a demo we've knocked together. And again, you can see here, you have to be quite careful about what cuts you're making. So just skip through those. And so now we've got the jaw cut, and now the surgeon would actually move the parts into place where he wants to improve the alignment. So it's a bit hard to see that in this demo, but the final result, you'll see that everything's been shifted. And there we go. So you can see this area here, the jaw's been shifted down a bit, and again, this part of the chin has been pulled out a bit, and I think there's some adjustments here on the sides as well. So the next thing is create some strip plates. I'm just going to set the next thing going. So we're going to create strip plates by picking points either side of these gaps and then creating smooth surfaces over the gaps. Now, sometimes these gaps can be very large and quite concave, or there can be quite different heights between the sides of the gaps, depending on how the bone has been moved. So we found a way of using Polygonica's shrink wrap to mitigate that. So the shrink wrap provides a wrap around the external surface that's very smooth. It's very, very tight and accurate to the original surface. But where these gaps are, it smooths over them. And we've added an extra option that does its best to preserve convexity across those surfaces, or at least not become too concave, so that you get a smooth surface on which to place the strip. So this orange skull is the shrink wrap version, and that's what we're going to actually create the plates on. So here we've got both versions in a transparent display, and as you can see, the surgeon picked 2 points. I'll just do it again. He picked 2 points on either side for the anchor holes, and then we used geodesic joining, pathfinding to join those points. And then we use Polygonica's curve offset across a surface in order to create the outer boundaries and the inner boundaries of the plate. We then imprinted new edges onto the skull, or a copy of the skull, found the inside faces from those edges, and used those as a surface on which to thicken using Polygonica's 3D offset into the strip. And then we did some remeshing, some smoothing, and some tidying up of the results, just to make sure it looks nice, and it's not going to be sharp it's going to be a smooth surface that goes inside the patient rather than lots of nasty sharp edges. So there's another one, and we'll just go and do some more here. So you can see the surgeon picking the the 4 red circles, and then Polygonic is automatically creating a plate from that. Doing it again here. And we'll do some more complex ones with junctions and more complex joins here. So that's a sort of typical fairly solid anchor, and you can also see how it maps nicely to the curvature on the plate. We'll do another one here on the surface of the skull, sorry, and here we go. And then one down the bottom. And there's the finished job. So let's just actually go in and look at some of those. So you can see here, we've got this complex plate on the bottom. If we look at it from the side, you can see it's mapping nicely to the surface of the skull, and also that these large gaps have been bridged cleanly, which is really important. Same thing with these ones here. You can see that the gaps are nicely bridged, and okay, maybe this one's a little bit close to the edge, possibly a surgeon wouldn't have placed it there, but I mean that's the purpose of this application, or part of the purpose of this application, to pick things up like that. Okay, so yeah, that's the general idea. If you want to find out more about this, or you want to get the source code, build it and have a play for yourselves, then you can contact us via the website, or contact the support team, or find us on LinkedIn and get in touch with us that way. And so thanks for your time, and thanks for listening.